Venus and Earth, twins born from the same cosmic cradle, almost the same size, forming in the same region of the solar system. Yet today, they couldn't be more different. One is a lush paradise, the other, a hellish wasteland. But how did Venus become this inferno while Earth became a garden? Venus is arguably the worst place in our solar system. Its atmosphere is 96.5% carbon dioxide, creating surface pressures 92 times stronger than Earth's. Temperatures soar to 470 degrees Celsius, hot enough to melt lead. Sulfuric acid rains streak the sky but evaporate before reaching the lava-scorched surface. In contrast, Earth's atmosphere and oceans create a temperate, life-supporting environment. So, what went wrong for Venus? Surprisingly, Earth and Venus are almost twins, yet one is a paradise, the other a cautionary tale. Long ago, Venus may have had oceans. Evidence comes from heavy water or deuterium lingering in its atmosphere, a clue that vast amounts of regular water once existed. So what happened to all that water? One theory points to the sun. As our star aged, it brightened, potentially boiling away Venus's oceans. But Venus spins slowly. One day is 116 Earth days. Thick dayside clouds could have reflected sunlight, keeping the planet cooler. If the sun wasn't entirely to blame, what else pushed Venus over the edge? The likely culprit? Extreme volcanism. Venus may have experienced large igneous provinces, enormous, prolonged lava eruptions. These eruptions release massive amounts of carbon dioxide. Without oceans to absorb it, and with limited plate tectonics, the planet couldn't sequester the greenhouse gases. Result? A runaway greenhouse effect. Temperatures rose, oceans evaporated, and Venus became the scorching, acidic world we see today. Earth avoided this fate thanks to plate tectonics and oceans. Subduction zones pull carbon dioxide deep into the mantle, acting as a planetary thermostat. Water is crucial. It lowers rock melting points, allowing tectonic plates to bend, break, and recycle carbon. Even during massive volcanic events on Earth, this system gradually restores balance, keeping temperatures stable and oceans liquid. Could Earth one day become Venus? Stephen Kane and his team ran simulations projecting 3.5 billion years into the future. As the sun brightens, Earth's oceans could begin to evaporate. Without water, subduction stops, carbon builds up in the atmosphere, and global temperatures rise past 100 degrees Celsius, boiling oceans, destroying surface life. However, Earth has one advantage Venus didn't. A stagnant lid would eventually form over the mantle, slowing volcanism and preventing CO2 from reaching Venus-like levels. In other words, Earth might become extremely hot, Venus light, but not as extreme as Venus itself. Venus shows the ultimate consequence of a planet losing its ability to regulate carbon. Earth's water and tectonics have protected us so far. Studying Venus isn't just about curiosity, it's a warning, a glimpse into what could happen if the delicate balance that sustains our planet is ever disrupted. Earth remains a garden in the shadow of its fiery twin. By understanding Venus's past, we gain insight into our own planet's future, and a renewed appreciation for the fragile conditions that make life possible. The question isn't just why Venus became hell, it's how long we can keep Earth an Eden.